measurement using the manometer. A simple manometer rule can be written, that says that start at any point in the fluid where the pressure has to be measured, and then proceed to add the pressure algebraically from one vertical fluid interface to next until you reach the liquid surface at the other end of the manometer. So what it says that if you want to measure the pressure at point A, you start from the here only. So this pressure is equal to this pressure. Then once you are going down at this location, so this is the height, which is the difference, which is your HBC. So whatever the pressure at C will be higher than the pressure of B by the amount of this much head. Your head will be HBC. Now you move to points D. So how much pressure will be increased? This height. And again, once you are reaching from this to this, the same pressure amount will be decreased. So you need not to count this one. You can directly write that pressure is at C is equal to pressure at D, and then you, once you are measuring rising from point D to point E, so the pressure will again reduce by the amount of the head of HDE. So the rule I just explained can be written in this term, that start at a point in the fluid where the fluid pressure is to be determined and proceed to add to it the pressure algebraically from one vertical fluid interface to the next until you reach the liquid surface at the other end of the manometer. So just using this rule, you can quickly get the pressure at any desired location. So using the manometer rule I just discussed a few moments ago, we will use the same rule for the calculation of the pressure at point A in this given simple manometer, and let's see how this rule works and how it is very easy to follow the procedure. So once before starting this thing, you have to remember that whenever you are moving downward 1 to 2, so pressure will be increasing, so gauge pressure will be increasing, and once you are moving, let's say this is point 3 and this is point 4, so once you are moving upward, pressure will reduce. We don't know what is the PA pressure, and once we are moving downwards, so PA is equal to PB, so you need not to write this thing when going from PA to PC. Okay, so how much pressure will increase? That is your height, that is your HBC, and density of the liquid which is filled inside is gamma. Now C and D are equal, so once you are right now at the point D, and once you are moving from point D to point E, how much gauge pressure is being reduced? That is height, that is your HDE, and multiplied by the gamma dash. Now this pressure will be what? Pressure PE. Now pressure PE is your atmospheric pressure. PE is your P atmospheric pressure. Now this is 0 in the terms of the gauge pressure, because gauge pressure is defined as the pressure which is measured with reference to atmospheric pressure. So gauge pressure at E is 0. So you can simply write E is equal to 0. So now if you simplify this equation, you will get the PA is equal to HDE multiplied by gamma dash minus HBC multiplied by gamma. Okay, this is the same expression you got in the previous discussion. If you want to verify, you see we are getting the same thing here. Okay, so whatever you have done here, you can quickly use the algebraic measurement from one location to second location, and you can easily get the pressure at any desired location. Using the same rule, we are taking another example, so it will be more clear to you that how one should use. So another example of manometer which is given to you, that is also, it is a manometer. Okay, so we want to figure out what is the pressure at A. So simply we can directly straightforward we can write that pressure A, we don't know what is the pressure at A, and once you are moving from this to this, this and this and this height which is you have traveled in this one, so this will be increasing pressure at this location, and similarly once you are moving from this to this, the same pressure is reducing. So that's why you need not to take care of this thing. So you can straightforward move from this point to this point. Okay, so right now you are at this location, and from this location you reach to point B, and the height between difference between the A and B is your H A B, and the liquid which is filled inside the manometer at this location is such that its density is gamma. Okay, so this is not plus, this should be minus. Okay, because once you are moving upwards, the gauge pressure will be reducing. Now once you are again moving from point B to C, so it will be minus H B C and multiplied by the density of the liquid filled, which is a different density, that is your gamma dash, equal to pressure at C. So pressure at C can be straightforward written as 0, because this is atmospheric pressure. In the terms of gauge pressure it will be 0. So if we rewrite the equation, that is PA minus HAB multiplied by gamma minus HBC multiplied by the gamma dash is equal to 0. So pressure at A is equal to HAB gamma plus HBC gamma dash. I hope so using these two simple examples it is more clear to you how we have to use the manometer in order to get the pressure at any location in the fluid. Now let's move to another topic, that is differential manometers. We have to understand that which kind of manometers are being used for which purpose. So many a times what happens that we are not interested to find out the gauge pressure or absolute pressure, as we noted in the case of the manometer and barometer. Sometimes we want to know what is the pressure difference between the 2 points. So if we want to use the pressure difference at point A and point D, we use this kind of differential manometers. So this is used to determine the difference in the used to determine the pressure difference between the two points in a closed conduit when the liquid is flowing. In order to measure the pressure difference at these two locations, we take a tube which is filled up with the any other fluid having the specific weight of gamma dash, which is attached to these locations. Then we can get the pressure by just using the principle we use for the manometer rule. Using this manometer rule, we can write that pressure at A is PA, and once we are moving in this direction, so once we are reaching at the location of this point, the height the height difference is HAB. So as we moved downwards, so the gauge pressure will be increasing. So we can write that plus HAB multiplied by the density of fluid that is your gamma, and pressure at B and pressure at this location will be same. So once we are moving from this to point C, so then the pressure difference, so this is a negative gate pressure, so it will be minus HBC, and the liquid here is gamma dash. And once we are moving from point C to D, the pressure difference again is minus times of HCD, and the liquid having a density of gamma. Okay, that is the water, and this will give you the pressure at D. Now if we want to know the pressure difference, so we can write that PD minus PA, that is your pressure difference, and we can give this name as a delta P, that is your pressure difference. So using the equation 1 and equation 2, we can write that delta P is equal to PD minus PA is equal to gamma, using this one, gamma HAB minus gamma dash HBC minus gamma HCD. Okay, now so another thing is that HBC is equal to HAB minus HCD. If you see BC is this side, okay, this side, what we have shown, BC, this is equal to HAB is this one minus HCD. So using this equation, we can simply write that pressure difference delta P is gamma minus gamma dash multiplied by HBC. Now there is one point to observe here, that if you choose this particular gamma dash value very close to gamma, so the difference between these two numbers will be also very low. So once the difference between the two densities is low, the height of rise will be high, and that's how you can get a precise measurement of the difference of the static pressure, or you can say difference in the gauge pressure at point A and D, or you can say the difference in the absolute pressure of point A and D. You remember this point, that although we are measuring the gauge pressure, but the difference in the gauge pressure will also be the difference in the absolute pressure. The differential manometer we just discussed is in the shape of U. So that is also called the U-shaped differential manometer. In case of when the measured pressure between the two locations is very small, then we can use a inverted differential manometer, which is shown over here. This is inverted U-shaped differential manometer. The principle is same. The only scenario is that once you are using the pressure difference at these two locations, the manometer which is connected, which was earlier in the shape of U, is now in the shape of the inverted U. You can see over here. So similarly, if you want to measure the pressure difference between the PA and PD, so we can again start with the same concept we use. What we can write is that PA, we are at the location at PA, then once we move upward, so we go for a height of HAB. So we are moving upwards, so there will be a pressure decrease, that will be HAB multiplied by the density of liquid that is filled up with this one is gamma. Now so along the same level we can go to this point, and now once we are moving from this point to point C, how much increase in the pressure is, that is plus HBC multiplied by the density of liquid that is filled up in this one is H dash. We have reached the point C, and once we are moving from point C to point D, we have again dropped a distance of HCD. So again gauge pressure will increase by HCD and multiply by the density of liquid, that is your gamma, and this will give you a pressure of now. So again we are defining that change in the pressure, which can be written as delta P, which is the PD minus PA. Now, so in order to get the PD minus PA, so we can move this A towards this one, and rest we can be written as PD minus PA will be these three terms. Okay, we have to just rearrange this one. So this will be minus gamma HAB plus gamma dash HBC plus gamma HCD. So we are knowing another thing, that the height HBC can be written as HAB minus HCD. You see this thing, this distance is sum up of these two distances. Now if we want to rearrange this thing, this again can be written as delta P is equal to gamma dash minus gamma multiplied by HBC. So what exactly expression says is such that difference between the specific gravity of the two liquids multiplied by the height of this difference. You can see HBC. So just you figure out what is the difference between the level of two different liquids and multiplied by the difference in the specific gravities of this one. You can quickly get the difference in the pressure of 2 points. Now what we can do for this thing, that making this value again very close, this rise will be high, so that we can quickly measure this. What we can go for the, like for example gamma dash and gamma, one you can take water and one you can take oil. Okay, so specific gravity is 1 and 0.9. Suppose instead of the liquid which is filled over here is your air, such that gamma dash is your air. So if gamma dash is air, so what will be the density of this one? This will be close to 0. So what in such situation, air is very light fluid, so we can pump into the top portion of the tube. Okay, we can pump the air from this location and just make the valve close to produce the suitable liquid level, so that we can easily measure the difference between this particular locations. Okay, so if we write that gamma dash is equal to 0, we can directly write that delta P is equal to, using this particular equation, this is minus times of gamma multiplied by HBC. This is applicable in the case of air. Now so there are many kind of modifications are happening. You can see that earlier we started with the differential manometer, which was in the shape of U. Then we moved for differential manometer, which is in the shape of inverted U. And similarly you may arrive some situation where these tubes which are vertical or horizontal, that can be used in the inclined tube. So some of common modification which we can witness in the case of the differential manometer is the inclined tubes. Okay, so in future lectures we'll discuss this aspect also. Now let's talk about the modern gauges. These gauges are called Bourdon gauges. You can see usually what we used to do as a application part, we used to measure the very high pressure in cases of gas, especially if you can see these types of gauges and you go for filling air in your tires, you can see such kind of gauge are available, okay, which is used completely for the measurement of the air pressure, which is whose magnitude is really very high. Okay, so why this kind of pressure is used? Because if you use the manometer in order to measure the high gas pressure, in such situations we need very high tubes, okay, and in such situation the handling will be very typical. So what is the principle behind this kind of board gauge is, we'll discuss it. So here if you can see, this is a coiled tube is over there. So this tube is such that this is open on the one side and closed on the other side. However, this closed size is such that this membrane is over there, which once you increase the pressure inside this coil up, this will open up. So once this will open up, this connecting link is over there. This will respond elastically, and this particular curved coil will be uncoiled with the change in the pressure. So corresponding to the movement of this particular thing, a pressure which will be shown over here. Okay, so now this is based upon the pressure increase in this particular coil. This can always be calibrated according to this one, and the readings which are, you can see since kPa, you can always get it. So our last section of today's lecture is pressure transducer. So these are the modern devices. So this is electromechanical devices where electrical aspects are also there as well as mechanical aspects are also there. That's why it is called as electromechanical device. Okay, so the best advantage of this particular thing is that this pressure transducer can directly measure the pressure with a very quick response. Okay, and also you can continuously measure the pressure change with the digital readouts over the time. This electromechanical device consists of two parts, part A and part B, such that these two parts are separated by a thin diaphragm, and on this diaphragm a strain gauge of known length is attached, such that this part A is connected to the vessel for which we want to measure the pressure, and part B is open to atmosphere. So whenever there is change in the pressure happens in the section A, or increase in the pressure in the section of A, this diaphragm attached to the section A elongates, and once this deform or elongates, the strain gauge which is attached to diaphragm will also change its length. Once length is increased of this strain gauge, definitely the resistance of this strain gauge will also change. With the change in the resistance, current flowing will also change. So correspondingly we can calibrate the change in the current and change in the pressure. We can quickly calibrate this system, and knowing the change in the current, we can quickly calculate the change in the gauge pressure. That's what is the complete principle behind the working of this such kind of pressure transducer. So one more additional thing is linked with the pressure transducer. This is a universal kind of measuring device where this can be used for the three different purposes. First purpose we just discussed, that if you want to know the gauge pressure, this can be measured from the pressure transducer, or you want to know the atmospheric pressure, yeah, or I should say absolute pressure, not atmospheric pressure, absolute pressure. This can also be measured with this device, and also if we find out the difference between the pressure at 2 points, this can also be used for the devices, pressure difference at the 2 points. Now how will be how these three different things will be used. First thing, which is the gauge pressure we just discussed. In this scenario, in the first scenario, let's say this is first scenario, this is second scenario, this is third scenario. So in the first scenario, what will be happen? A and B, let's talk about the A will be attached to the vessel and B will be open to atmospheric. Then it will give you the gauge pressure. Okay, now let's talk about the point 2. When you want to know the what is the absolute pressure, in this situation you will attach the A with the vessel where you want to know the absolute pressure, and B should be closed and as should be vacuum one. Then you can figure out the absolute pressure. And if you want to note down the pressure difference between the two locations, so A and B both should be connected to the different vessels. So whatever the pressure difference between the two vessels will be there, that can be measured with the this situation. So this you can say that it's a versatile kind of device is there. And in the modern industries where the pressure measurement is are done, there are such kinds of gauges are transducers are used for the measurement of the pressure. So with this note, we just conclude our today's lecture. So here is the summary. So for the measurement of the pressure in the static condition, the pressure measurement which was done by the various kinds of devices. So first of all, we studied the barometer. So this barometer was used, I mean is being used for the knowing the atmospheric pressure at any location. Okay. Second thing, we studied the manometer. And in the manometer there are different manometers are there, like for example simple manometer we used to study, and simple manometer. And second, we use the differential manometer. Differential manometer, this was used to in order to find out the difference of the pressure at two different locations. However, in the simple manometer we were just measuring out the gauge pressure at any location. And again, this was two types, where U-shaped and inverted U-shaped. So along with this one, we have also studied the Bourdon gauge. And last one was the pressure transducers. With this all discussion, we can easily understand how the pressure are measured in the fluid in static condition.